All right, day 2 of 11.3. Again, we're talking about probability of multiple events. Day 1, we did a lot of definition on independent, dependent, and mutually exclusive. Today, we're going to focus on what's the probability of event A or event B occurring. In day 1, we talked about probability of both event A and event B occurring with independence. But today, we're going to focus on the or. As a quick little get our brain going, what is the greatest common factor of 42, 126, and 210? A lot of ways to do this. Basically, what's the largest number that can multiply in a whole number of times to 42, 126, and 210? What I like to do is I start with the smallest number, 42, and I just check to see does 42 go into the two larger numbers? It goes into 126. But does it go into 210? 210 divided by 42? No, it does not. Oh, it does. Wait, what? All right, try to do it in my head. That didn't work. Not going to cut that error out. We'll just leave that one there. So there's my answer, 42. But if 42 didn't work, then you would go down. What's another number that goes into 42 and check all the other ones? My God. All right, let's move on. A big thing, a big piece that you're going to see in any sort of probability assessment or exam, whether it's in this course or when ACT, PSAT, whatever, is the phrase with replacement versus without replacement. So, for example, what is the probability of drawing consecutive aces with replacement? And what that means is after I draw the first ace, I'm going to reinsert that card back into the deck. So if I think about what's the probability of the first card being an ace, okay, well, there's 52 cards. 4 of them are aces, so it's 4 out of 52. Now, that does reduce to 1 out of 13, but not super essential. So this is the probability of ace. Now, if there's replacement, that means the ace that I draw goes back into the deck. So what's the probability that the second card is an ace? It's also going to be 4 out of 52 because that first ace has made it back into the deck. So 4 out of 52 or 1 out of 13. Okay. Now, if we're talking about the probability of back-to-back events occurring, those will be multiplying. Okay. If I want the probability of the first event, which is an ace, 1 out of 13, and then followed by another ace right after that, this would be the probability of ace. Then another ace is going to be 1 out of 13 times 1 out of 13, which is 1 out of 169. It's not even, the numbers aren't even that important. I just want to focus on the phrase with replacement, okay? And that means that the probability for the first one is the same as the probability for the second one. If the question says without replacement, I don't know why I didn't bold replacement, that means that, okay, probability that the first card's an ace is 1 out of 13, we just saw, or 4 out of 52. Now, what's the probability that the second card is an ace? Second card is an ace. Okay. Well, it's no longer 4 out of 52 because we are not putting the first ace back in the deck. So there's only 3 aces remaining, and there's no longer 52 cards to pick from. There's only 51. Okay. Well, 3 out of 51 does reduce to 1 out of 17. So if there's no replacement, the probability that I draw an ace and then another ace. And again, when we're talking multiple events, if they are back-to-back events, what's probably you draw an ace and then you draw another ace. Okay, I'm going to take those individual probabilities and multiply them together. 1 out of 13 times 1 out of 17. 13 times 17 is 221. This is 1 out of 221. Okay, so with replacement, that does not change the probability. Without replacement, does change the probability. Okay, so that does affect my overall. Another way to think about this first example. This is independent. This makes the events independent, and without replacement means that they are dependent events. Okay, let's move on. All right. 150 students were asked about their favorite social media app. 74 students said Instagram, 61 said Snapchat, and 15 said Facebook. What is the probability someone chosen at random prefers Snapchat? From what we can tell, we're only picking one person, right? I'm only choosing one person at random. So I know my sample space is going to be 150. How many my event space or my event is that they prefer Snapchat? It very clearly shows that 61 people prefer Snapchat. So 61 out of 150 as a decimal is 0.406 repeating. I don't know if that reduces. It does not. 0.406 repeating. If it says probability that someone prefers Instagram or Facebook, again, I'm only picking one person. So my sample space is still going to be 150. But now I want what's the probability that they prefer Instagram or Facebook. There's two ways to do this. I can either take the 74 Instagram and the 15 and add those together and get 89 out of 150. Or as we saw a couple of videos ago, your other option would be, since you know there are 61 people that prefer Snapchat, you could just subtract the 61 people, and then you know the rest are either Instagram or Facebook people. So 89 out of 150, again, I do not think reduces. Decimals 0.593 repeating, about 59%. 0.593. Okay. So if you're picking one person, there's no multiplication involved. But if it uses the word or, you're going to be adding the Instagram people and the Facebook people. Okay. So to get to our EQ, what's the probability of A or B occurring? Okay. And again, we get a new symbol here. The mathematical the mathematical term for this is union. But for what we're doing in this course, you should think of that uppercase U as the word or. So the probability of A or B is simply the probability of A plus the probability of B. Now, this is only true if two events are mutually exclusive. That's a very key piece that I didn't talk about. If two events, remember, mutually exclusive means they cannot both occur. So if two events cannot both occur, then the probability of either event occurring is just the sum or the addition of their two individual probabilities. We'll see what happens if it's not mutually exclusive in just a second. All right, so 500 students were asked two questions for a survey, simple two-question survey. Do you play sports and do you play a musical instrument? Okay, so again, 500 people were asked. 200 people play sports, 150 people play a musical instrument, and 50 people play both. What is the probability of choosing a student that plays sports or plays an instrument? So what is the probability of sports or an instrument? I'm just going to use the word or. Okay. What's the probability of sports or an instrument? Now, if we think about, well, the probability I pick someone who plays sports is 200 out of 500. Plus the probability, now how many people play instruments? Well, that's 150 out of 500. Okay. And so it would stand to reason based on what we just saw that the answer is 350 out of 500 or 70%. But this is not correct. And do you know why? The reason that 70% or 350 out of 500 is not correct is because of this little tidbit right here. And that's the fact that 50 people play both instruments. So what's happening is when I add these two numbers together, there are 50 people that are in both the 200 figure and the 150 figure. And so I'm double counting those 50 people. So what I instead need to do is take this 350 and subtract off the people that I double counted. So the true probability of picking someone who plays a sport or an instrument is 300 out of 500, which is 0.60 or 60%. Okay. Now, we're going to look at a definition of what we just did, but the idea that if both events can occur, there has to be some sort of subtraction. Otherwise, you are double counting people. And sure enough, that's what we call you're subtracting the overlap. Okay, so if two events are not mutually exclusive, you have to subtract the overlap between the two events. So now we get to use both our fancy new symbols. We get to use the or, we get to use the and as well. Okay. So to find the probability of A or B, you add up the total number, but you have to make sure you subtract off the overlap. And the reason we didn't have to worry about this 2 slides ago is because if you think about if two events are mutually exclusive, right? If it's true that they're mutually exclusive, then they can't both occur. So there is no overlap, so I don't have to worry about double counting. So this is the big chunk that we're going to use and see if I can finish before the computer dies. Now we only got one problem left. So you're going to pick one of the shapes from the ring below. What is the probability that the shape is a square or it is red? So what is the probability that the shape is a square or it is red? Okay, so that means I'm going to take the probability of picking a square plus the probability of picking a red shape. I'm going to subtract off the probability of a square and a red shape. So what's the probability if I pick one item that it's a square? Well, in here I count 1, 2, 3 squares. So this would be 3 out of 9. I think there's 9. 4, 5, 6, 7, 8. Yeah. So 9 items total. What's the probability that I pick a red shape? Well, the red shapes are 1, 2, 3. There are 3 red shapes total in that ring. So this would be 3 out of 9, which would reduce to 1/3. But the problem is there's not 6 items in that ring, right? Because right now 3 plus 3 is 6. I have to subtract off any shapes that are both square and red. And that's that one right there. So because this is both square and red, I double counted that, so I have to subtract off 1 out of 9. Again, with fractions, you can always just type it in the calculator, but you don't need to here. Since they're all over 9, I can just add or subtract the numerators together, which is why I didn't reduce. So 3 plus 3 is 6, take away 1 is 5. So the probability that you choose a square or a red is 5 out of 9. Okay, so that's our probability for this. Our summary is how can I find the probability of event A or B? So we're going to say the probability of A or B is equal to the probability of A plus the probability of B, and then minus the probability of A and B. Okay, so a couple things here. This means or, this means and then what else did I want to make sure we touched on? Yeah. In general, if you see the word or, now this isn't always, you're going to be adding numbers together. And if you see the word and, again, this is a generalization that lends itself to multiplication. Not all the time, but it's just something that we want to keep in the back of our brains. Yeah, we're done.